All right, welcome. Today, we're going to pull back the curtain on one of the most powerful ideas in all of networking, the VLAN, or Virtual Local Area Network. Seriously, by the end of this, you'll understand the secret sauce that makes entire corporate and school networks tick. Okay, let's jump right in.
So let's start with a question you've probably experienced. You go to an office, you log on to their guest Wi-Fi. You're using the exact same wireless box on the ceiling as all the employees, but there's no way you can get to their private files, right? How does that work? Well, the magic behind that separation is a VLAN. To really wrap our heads around this, we're going to use an analogy that makes it all click. Think of your entire network as one giant apartment building. But right now, it's a very strange building, one with no walls.
So your physical network switch, that's the building itself. And every single device you plug in, a computer, a server, a printer, is like a person living in an apartment. Now without VLANs, the walls are basically paper thin. Everybody's on one gigantic, wide-open network. In networking terms, this is called a single broadcast domain, which is just a fancy way of saying when one person shouts, everybody in the entire building hears it.
And as you can imagine, this creates two massive problems. First up, security. It's a disaster. With those paper-thin walls, the sales team can snoop on the top-secret files the engineering department is working on. Absolutely not good. And second, performance. All that constant shouting from every single device, all that broadcast traffic, it just clogs up the airwaves and slows the entire network down to a crawl for everyone. It's a mess. Now, the old-school solution was to just build completely separate buildings. One for sales, one for engineering, but that's incredibly expensive and a total nightmare to manage. So instead, we use a much, much smarter solution that's all based in software. It's time to paint some doors and build some virtual walls.
And here it is, the official definition. A VLAN lets us take one physical piece of hardware, or one big apartment building, and logically, virtually, chop it up into many smaller, totally separate networks. That word logically is the key. We don't touch a single cable to do this. It's all done in the switch's configuration. So how do we do it? Well, it's pretty straightforward. We create our virtual groups. We give each group a name we can understand, like families or students, but more importantly, we give it a unique number. That's the VLAN ID. The switch doesn't care about the name families, it only cares about the number 10. You can think of this as assigning a unique color to each of our new groups.
The best part is how simple this process really is. Step 1, we define those virtual groups we just talked about. Step 2, we tell the switch which of its physical ports belong to which group. This is literally like painting the door of each apartment the color of the group inside. And the result? Presto! Instant, magical, virtual walls appear, separating all the groups from each other.
And this is the crucial takeaway. Once a port is painted blue for VLAN 10, any computer plugged into it can only talk to other computers in other blue rooms. That's it. The green rooms are in their own little universe, and the red rooms are in theirs. The shouting from one group is now totally contained. It doesn't bother anyone else. And just like that, we've solved both our security and our performance problems.
Okay, so this is great. We've successfully isolated our groups. Everyone's secure. The network is running way faster. But this brings up a pretty logical next question, right? What happens when two different groups actually need to talk to each other?
Exactly. What if someone in the families group needs to print a document on the big printer over in the businesses group? As it stands right now, they can't. That virtual wall we built is a solid brick wall, by design.
The solution has a name, Inter-VLAN Routing. And to make this happen, we need to introduce our building manager. In the world of networking, the building manager is a router. Now, if someone from the families group wants to send a message to businesses, they can't just shout across the hall. Nope, they have to send their message up to the router. The router then looks at it, checks the rules, and if it's allowed, it forwards the message to the correct VLAN. The router is the gatekeeper.
So now that we've got the big picture nailed down, let's learn a little bit of the lingo. We're going to translate a few more pieces of our analogy into the real-deal technical terms that network pros use every day. First up is the access port. This is your bread and butter, the most common type of port you'll ever configure. An access port belongs to one and only one VLAN. That's it. In our analogy, it's just a normal apartment door, painted a single color. This is where you plug in your everyday devices, like your PC, your IP phone, or a printer.
But what if you have more than one switch? What if you have two separate apartment buildings, and you want your blue group of families to have rooms in both buildings? For that, you need a trunk port. A trunk is a special kind of connection between two switches that's designed to carry the traffic for all of your VLANs at the same time. Think of it like a secure, shared hallway that connects the two buildings. So you might be wondering, how does that shared hallway keep everyone from mixing together? Well, it uses a process called VLAN tagging. When a piece of data from a blue computer wants to cross that hallway, the first switch adds a little digital ID badge to it that says, "Hey, I belong to VLAN 10. When it gets to the switch on the other side, that switch reads the badge and says, "Ah, VLAN 10, I know exactly where you're allowed to go." It's a really clever system.
Okay, understanding these ideas is one thing, but in networking, real understanding, true mastery, comes from doing. So let's talk about how you can take all this theory and really make it stick.
The absolute #1 best way to learn this stuff is to get your hands dirty. And you want to do that in a safe, virtual space. A tool like Cisco Packet Tracer is amazing for this. It's basically a free video game for network engineers. You can build massive networks, configure everything, and most importantly, see what happens when you break it, all without taking down a real company's network.
So I've got a challenge for you. 3 missions to lock in this knowledge for good. Mission 1, just use a single switch, create 2 VLANs, and prove to yourself that they are completely isolated. Mission 2, bring in a second switch and connect them using a trunk port. And finally, the boss level, Mission 3, add a router to your network and configure Inter-VLAN routing so your groups can talk to each other under your control. If you can do these 3 things, you've got this.
So, let's do a super quick recap. If you remember anything from this, remember these points. VLANs are virtual walls that you build inside your network. They are absolutely critical for security, and they give you a huge performance boost. They give you the flexibility to organize your network however you want. And finally, if you want those separate virtual worlds to talk, you need a router to act as the gatekeeper.
And we'll end on this thought. The real power of VLANs is that they free you from physical limitations. You can design your network based on how your organization actually works, not just where the cables happen to be plugged in. You can group people by department, by project, by security level, whatever you need. So the real question is, now that you know how to build virtual walls, what kind of network are you going to design?